Silica. It's small, deadly, and extremely common around construction sites. But how can you control it to keep yourself and your employees safe? Hi, I'm Sergio with Arthur and Hansen, and today we're going to be talking about different ways of controlling silica hazards. As with any hazards that exist on a work site, silica hazards must be controlled appropriately to protect exposed employees. Of course, the process begins when hazards are identified, along with the risk associated with that hazard. Once that is determined, appropriate ways to eliminate or control the hazard must be implemented to protect the exposed employees. In this video, we're specifically going to cover the methods used to protect employees from respirable crystalline silica. As we know, employees are at risk when exposed to silica that they can breathe in. When a company's worker or workers are exposed to silica above the permissible exposure limit, which is 50 micrograms per cubic meter of air over an 8-hour time-weighted average, then an employer has two options for limiting employee exposure to silica. 1. Specified exposure control methods, or 2. Alternative exposure control methods. Employers who choose the specified exposure controls option must fully and properly implement protections for the task or equipment listed in Table 1 of the standard. When these controls are fully and properly implemented, employers do not have to assess employee silica exposure levels or keep employee exposures at or below the permissible exposure limit. If you're getting a little confused at this point, don't worry. A more detailed description of Table 1 on how to read and use it is explained in this video here. But in the meantime, we're going to give an overview of the control methods listed in Table 1 used to mitigate silica hazards. The controls listed on Table 1 include engineering controls, administrative controls or work practice control methods, and required PPE, in this case, respiratory protection. Let's start with the engineering controls. These types of controls require a physical change to the workplace or procedure. In the case of silica hazard control, the engineering controls include equipping the tool you're using with an integrated water delivery system or using a dust collection system. The purpose for these engineering controls is to keep silica out of the air when drilling, cutting, or disturbing the material containing silica in any other way. When the tool is integrated with the water delivery system, water is continually supplied to the material surface or to the point of impact to suppress and reduce the dust emissions. This essentially eliminates the risk of breathing in respirable crystalline silica, as it eliminates exposure to the silica dust. Another engineering control mentioned in Table 1 is providing the equipment with a shroud and dust collection system. When designed and maintained properly, a dust collection system can help reduce the amount of airborne silica dust. Now with both of these engineering controls, one of the greatest advantages is that you can install these controls only once and requires little to no training of employees for them to work properly. However, we can't just slap the dust collector on the grinder and forget about it. This is where the administrative controls come in. Administrative controls and work practices alter the way that the work is done, including timing of the work, policies and other rules, and work practices such as operating procedures. Now, the administrative controls specific to silica exposure include operating and maintaining the tool in accordance with the manufacturer's instructions to minimize dust emissions. In addition, those engineering controls you set in place, such as the water delivery system or the dust collection system, require maintenance and inspection as well. For example, when a dust collection system is being used, the filter and the vacuum should be cleaned or changed in accordance with the manufacturer's instructions to avoid any clogging. Another work practice that is often overlooked is good housekeeping. The cleaning of dust, when not done properly, can result in dust becoming airborne and exposing anyone around it. Now, one of the main reasons that it's often overlooked is because this activity doesn't involve working on the actual material containing silica. Instead, the worker is simply just cleaning up the mess after the fact. So, whenever performing housekeeping involving any sort of dust, make sure you do not dry sweep the dust unless it is wet down first. You're using a filter vacuum, or you use any other methods that minimize the exposure. Compressed air should also not be used to clean any clothing or surface containing dust. Great, so you've implemented the engineering and administrative controls listed in Table 1. Now it's time to consider any additional protection. The additional protection would be PPE. More specifically, respirators. Respirators should be used as additional protection and not as a standalone protection. Most of the activities listed in Table 1 do not require respiratory protection after implementing the required engineering and administrative controls. But when they are required, be sure that they meet the minimum assigned protection factor listed on the table. Now, we hope this video helped you gain a better understanding of the control methods often used to control silica exposure and how they work. If you need any help with your silica exposure plan or safety program as a whole, feel free to contact us using the information provided below. Be sure to leave a like on the video and subscribe so you don't miss out on any more safety videos like these. Also, let us know what topics you would like for us to do in the future in the comments below. As always, make sure to follow us on all social media platforms to stay updated with our latest safety tips and tricks. And until next time, be safe and thank you.